Hey everybody, Mr. Bress back here with our final video from the evolution unit. And in this one in the lecture guide, there wasn't much of a lecture through the slideshow. We did most of it on the lecture guide. And here we were trying to make some predictions ahead of time. So we were going to act like scientists and we're going to try to understand how a scientist or ourselves make a prediction based on several theories of where we would expect to find transitional whale fossils in various layers of rock, and then compare that to what paleontologists have actually found, and then be able to say, oh yeah, this theory fits the actual evidence better, or this one fits it worse. And then be able to try to get a sense of how scientists actually test their theories, and maybe get a better understanding of what's actually there in the fossil record. So let's move on over to our lecture guide, and let's see how this went in class. All right, here we are. Okay, so to start with in this, here we are in the fossil similarity. We started with actual sort of recreations of transitional fossils that scientists found that they believe are in the transition from four-legged walking mammal to more modern day whales. And there's a variety of reasons of why paleontologists believe that these are all of these animals are related. And it has to do with some bone structures that you can't see here, that are in the inner ear that are very unique to modern whales, that were found. The same structures were found in these older fossils, that has no modern animal has the similar structure that's found in these four-legged animals that's also found in modern whales. And there's some other relationships in the ankle and sort of foot bones that, believe it or not, that are still carried in whales today, that have these same sort of ankle shapes, that are very, that are unique to these animals, and happen to be still present in whales. So a variety of anatomical features, including also where these animals were found, when they were found, that scientists believe that these are all a piece of the same sort of branch of evolution. So the first thing we did in class was, and there's no right or wrong answer here, was to try to cut those out, those shapes out, and place them in what we thought was a natural transition from four-legged walking animal to modern whale. And we talked about the skull shape, the rib cage, the legs started moving more towards fin type appendages, as the hind legs start really become almost disappear, and all the way up to this modern whale. So we discussed a few of the features that led us to this conclusion, that this was the what we would predict would be the age, or sort of the transition. Then we looked at three different theories, and we then cut out different structures of whales and placed them in different rock strata. Remember, strata is just a fancy word for a layer of rock. And the layers of rock are dated. So the ones at the bottom, that rock is aged to about 50 to 52 million years ago. And then it goes all the way up to the youngest rock, which is about 40 to 42 million years ago. And again, there's no right answer here, but you want to be able to defend your principles a little bit of why you chose this. So in theory one, we said all life on the planet was created at the same time. During a great flood, the majority of animals died except for two of each species. So you could probably design this in a number of ways, but if this were the case, if all life was created at the same time. Now remember, these strata are 2 million years old, so there's many, many, many generations of a given animal will exist, be born, die, and go through many cycles of generations before the animal actually really has noticeable evolutionary, right? Their traits are being selected for all the time, but in large scale, we're not going to see a totally new fossil. Um, it's going to appear in a whole new layer of rock. So what we'd expect though is if all life was created at the same time, that we should see a mixture of all of these fossils together at some point in time. That's a critical feature. If all life was created at the same time, we should see a mixture of all of these fossils. The idea would be that all of these lived basically at the same time. And by random chance, they should all of them would have had members of their species die within a 2 million year period. So we should see them all at the same time. Okay. Um, Once again, theory 2 says all life on the planet was created at the same time. Certain species have become extinct over time due to unknown causes. So you could set this up in a variety of different ways, but the underlying theme would be that somewhere in there, you should see all of these different animal fossils and one given layer of rock. Because at some point in time, they would have all existed together. Okay, so we should see that somewhere. And then we should really see kind of no rhyme or reason to where we find different fossils in the rocks. The final one was that all life on the planet came from a common ancestor and have evolved to become the millions of species we know today. Due to limited resources, certain species evolved to outcompete more ancient species. The ancient species go extinct and are replaced by the more modern species. The pattern has repeated throughout the history of the Earth. So I put this in the way that scientists believe that whales have evolved. But if you flip this, it actually would still fit the logic. The biggest, most important thing is that these different animals, fossils, will not exist in the same strata. You'll never see this modern looking whale down here with a very prehistoric looking four-legged animal. They won't mix like that. There's going to be a kind of a natural progression. You don't see these in the same area. Right, so you never see this fossil up here and down here. That's not the theory that goes with animals going extinct over time. So we used this is a kind of a graph in a way where these are the kind of artist renditions of a number of the different fossils that we were looking at and the age of those fossils down here, from anywhere from about 55 million years old to around 40 million years old. So we use that to put the age of these fossils here. So this it goes from this four-legged animal was discovered in rock that was about 52 million years old. And this Basilosaurus, the very close relative to modern whales, was found in rock 40 million years ago. And these other, what look like transitional species, kind of on their way to becoming modern whales, were found in rocks that were aged in between in a very sort of predictable way. That's just the way they were found. So when we graph that, oh, and I guess we didn't do this in class. If we were to graph this in class, it would look something like this. So we would paste this one in here. Which one comes next? This one looks a little bit more like it has a tail. That one's next. And then I forget which one we like to be the, maybe this one is our next closest. right? So that one was 46 to 48 million years old. Oh, I got it. I always mess these. Oh, no, that's right. That's right, right? And then, yeah. And I'm sort of approximating a little bit here, but this one would go here. And then we have almost whale looking here. And then finally here. And this is, I'm basing that off of these ages that we recorded here, which are approximate, from this actual graph that paleontologists have put together of these fossils and the age of the rock that those fossils were found in. And so this looks very much like theory 3, this sort of idea that animals existed, traits were favored. As climate changed, these animals went extinct, and the most common animal was sort of a version of the one prior to it. And one thing that's important is that you never see, like this fossil, you never see it alongside this other modern one. So like you wouldn't see it here and here. There's never that. It's always a logical progression. So you never see that mixing. And that gets to these passages by Dr. Richard Dawkins that says that the one thing that if it were ever found that scientists would really need to reconsider their current understanding of evolution would be that if you saw a modern fossil, the skeleton of a modern fossil, a modern animal in older rocks. So if we saw a fossil like this that we found in rocks 40 to 42 million years ago, and we also saw it down here, scientists would really have to reconsider our understanding of evolution of whales in this sense. We'd have to say, if this is the case, then it's unlikely that this animal was an early ancestor, or we'd have to really rethink what would make sense. We'd have to create new hypotheses and test those. So far, though, in many years and many scientists are looking, we never see something like that. We never see like the skeleton, like a fossilized skeleton of a modern rabbit in rocks that are 100 million years old. Because the thinking is that rabbits evolved from some common ancestor, and rabbits look the way they do now, but they didn't look that way previously. And I think in class we talked about that for quite a bit because it's a very central point, right? So at any point in time, a scientific theory could be falsified, could be proven wrong. If something like that were found, if the skeleton of a modern animal was fossilized in rocks that were much older, where you would not expect them, and it was real, and it was found maybe a couple times, so we have a lot of confidence that it's right, and it's unexplained by any other mechanism, then scientists would have to reconsider. But that's the whole point of science. We try to look for these things. We're constantly looking for things to disprove our theories. And the same has happened for evolution. And the more evidence we find, the more it sort of strengthens this overall idea that Darwin first put forward, that animals adapt to their environment, certain traits are favored, and over time, as you favor more and more different traits, the animals start looking more and more different from their original ancestors. And we've seen that throughout this unit, time and time again, that the Earth is quite old, There's mechanisms we've seen to really select for traits. We saw that in dogs and other crops. That selection pressure happens in nature. When we experiment with it, we see predictable changes like we did with the guppies. And we would predict to see major changes in the skeletons of animals in the fossil record, and it's exactly what we see. So scientists are continually to test the theory of evolution, and every year we get stronger and stronger pieces of evidence to confirm this concept, this idea of how life became the way it is on our planet. And there's even more evidence, a whole chunk of evidence that's the DNA evidence that's come out in the last 20 or 30 years that also really fits with exactly the same theory. And it doesn't have to. It didn't have to be that way. We had this theory was very well established and very well supported even before we got in the DNA data. The DNA data could have totally falsified the theory of evolution, but it didn't. It just strengthens it. And so that's why, just like gravity, just like a heliocentric solar system where the planets revolve around the sun, evolution is very well supported by many different fields of science. So I hope this was interesting to you. I hope it was a new perspective of looking at evolution. And good luck studying, good luck on the test, and I will see you soon. Bye-bye.